Hey everyone, very big welcome to our DevFest for today, DevFest 2020 for GDG Cloud Singapore. Really happy to see quite a number of you here today, and we have many exciting topics and speakers who will be sharing their experiences with you today. So we hope you can join them, and if you have any questions along with their topics later on, do feel free to ask in the chat. We'll surface them during the Q&A. And yeah, we'll get to talk about it and discuss their topics later on. Anyway, my name is Hairizuan. I will be doing the opening note over here. So let's talk a bit about GCP this year, as well as what has happened, transpired over this entire year. Okay, so before we go into the meaty parts of this topic, I just want to mention that I'm going to be sort of link dumping a bit here and there. Okay, I'm going to paste this. We're going to copy and paste this link later on. I have it here as well. Let me see if I can paste it directly to the chat. Right, so the important thing here is that all the links that I will be showing in some of the slides will be within this one single gist. And you can just use it and check out the different resources that is out there for your own learning. And yeah, don't worry so much about each of the links there. Once you have that glossary, in fact, you sort of have the guide to everything. Okay, let's get into the proper portions. All right, so last year for DevFest, we asked this question, what exactly is DevFest? And I think, yeah, I end up writing a lot of one-word answers of what exactly is DevFest, and there isn't really one answer for DevFest. But I think this year, Google, one-up us and actually give a proper definition for DevFest. And yeah, I think just to round it up for those who might be joining us, maybe for the first time today for DevFest, it's kind of like the accumulation of events for one single year for the volunteer groups, especially for GDG, WTM. In the case, this year, we were also very excited to have Google Developer Space join us as well. And it's all the accumulation of all these events where we come up to this climax where we share with you, the grand learnings that we had over the year, be it for other events like Cloud Next or IO, Google I/O. Yeah. So this year, of course, things have been a bit different, but there have been things happening as well. And I think our speakers today will be able to show you, the things that they have learned and what they can share with you from there. All right. And because we mentioned, it's a place of learning. Okay, sorry, just one thing to mention. Just now within the text itself, you might have seen that they actually mentioned is from October 17 to 18. But the idea is that for us, actually this year, we are collaborating with a bunch of GDG groups and WTM as well as Google Developer Space. So we're actually running this campaign right now called 1 Month of Festivities, which has actually started earlier this month from 10th of October. So we are on week 4 of week 5 of all of our programs. Earlier this morning, there was the GDG Singapore did the variant for Android. And we're going to see 2 more sessions coming up next week. So next Saturday. And yeah, you can actually check out this link over here to find out more about those. It's in the glossary as well. So you can just click that link directly there. Okay. All right. So let's talk a bit about what has happened to Google Cloud in 2020. Of course, COVID-19 happened. Things have changed. Cloud Next, basically it wasn't a physical event anymore. And basically it got shifted to the online variant. So now it's called Cloud Next on Air. You can actually go to that link to find out more about Cloud Next. But to give you a summary of what happened, essentially it was, instead of having a list of activities, in a physical Cloud Next where it happened in less than a week, now you have an event that spanned over 9 weeks for 9 different topics. And it was really exciting because every week they will release over 20 different videos, so sometimes even 50 over videos on the topic itself. Okay, so if you're interested in any of these topics, in fact, right now, they have already changed it to sessions on demand, which means that you can actually watch those videos. Back then it was, they released it as part of the program. Now you can watch it at any time, as long as, this is something that you want to learn about. And I would very much encourage you to explore certain aspects of it. For example, if you are a DevOps engineer or you're interested in SRE and you want to learn more about how you can use certain tools in GCP to support some of the knowledge for your roles, you might want to look into some of the sessions that they have over here in regards to the new tools that they have. Okay, but if you just want to look at have a grand overview of what has happened, no worries. there's also summaries out there that focus on these things. For example, there's this blog post that actually summarizes what has happened over those 9 weeks. So do check out this blog post. I think we've plugged it quite a number of times, but it's really useful for you to get started in understanding what transpired in the 9 weeks of Cloud Next. Okay. So instead of just talking about Cloud Next, which is the grand event of for Google Cloud, I think we really want to talk about what are the big things that we need to look out for, or rather what things came out this year. In 2019, we had Anthos, we had Cloud Run. This year, we had something kind of in a different flair, but similar in a sense as well. In that Anthos was meant to be sort of the solution to a cloud provider agnostic solutions. BigQuery Omni, as you see over here, is that answer to it for BigQuery. And for different people out there who might be using BigQuery for your roles, you might be lamenting at times that you could only using Google Cloud. But Google Cloud has looked at moving away from that model where you have to be locked within a cloud provider, allowing BigQuery to be run under the hood of Anthos. So you can see over here, you're able to use it in Google Cloud, AWS, and Azure. Okay, but just one big thing here. Of course, if this is the first time you're seeing this, it might sound very exciting, but this is in fact when they announced this sometime in July, it was only in alpha. I think it was kind of like an invitation-only program. But similar to Cloud Run or Anthos as well, as they announce it, usually a few months later, they will start opening up for beta and getting more people to use it. So if right now, I believe this is not out right now for public usage, but in time, you should be able to get to use this. So if you're already on BigQuery, I think this is something very, very exciting that you can prepare for, especially if you are part of a company that uses multiple cloud providers. Okay. So yeah, I think I've mentioned about Anthos, and Anthos is about being able to use different cloud providers for managing your systems. In the same light, BigQuery is built on top of that to be able to be cloud agnostic. You can use it across different cloud providers. So if you're interested, you can read more about this at this link over here. Okay, besides BigQuery Omni, what are the other big things that happened? Well, Cloud Run is something that came out in 2019. I believe it went to generally available somewhere later of 2019, which is I think October or November. Okay, and they didn't stop there. Cloud Run itself is a containerized approach for serverless solutions, but they went further ahead this year. They introduced many more updates to keep it on par with current serverless tools like App Engine. For example, things like being able to have a longer timeout, setting minimum instance, certain controls that are kind of already intuitive with other serverless tools. They have started adding them in for Cloud Run. So it has been really, really exciting to see them roll out. You can see over here many, many different changes and updates in regards to Cloud Run. And if you are already on Cloud Run, I think this is very, very good news for us. Of course, because this is the Singapore variant of DevFest, we cannot get past, I need to announce this because I was also very happy when I saw this. In our region, the Asia Southeast one, Cloud Run was made available in July. So this was a bit overshadowed by the events in Cloud Next. But yeah, if you have not heard about this, yes, you can actually run it in our own region right now. So if you are a local startup that wants to tap on serverless tools like this, you can actually use it, localize it in our region if your clients are, especially all of them are based in this area as well. Okay, beyond Cloud Run and BigQuery Omni, the other big surprise that came out from Cloud Next this year was actually MLOps. MLOps is not a tool like the other two. It's more like a methodology. It's more like a understanding basically how you want to run your systems in regards to ML. And I think they have very much compared this to the current system, the current mindset of DevOps. So if you look at when you are running a DevOps operations in your company, you're looking at things like building up automation, having a CI/CD pipeline, so on and so forth. And the idea was set in, why can't we do this? Rather not saying why don't, but why can't we do this for ML? And if you look at it, in fact, they have placed it very nicely, very aptly in this diagram that, in fact, a lot of the same stages are quite similar to what you would have to do manually in ML as well. So that's where they came up with the idea of ML Ops. And so you can actually go to this link over here to get a deeper understanding of their comparison between DevOps and ML Ops. I don't go in too deep about this. It probably would be better for you to actually get a better understanding by looking through from their documentation. on how you can actually do it. But in fact, I think if you look at one of their descriptions, essentially it's the summarized form is something like this. The CI in your local, or rather in your regular DevOps, you'll be thinking about things like testing, validating code and components. But in the case of MLOps, you want to look at additional things like your data schemas and models. And within the entire pipeline as well, there's also a new component for MLOps called continuous training. Okay, so this is unique to ML systems only. So if you're really interested in looking into this area as well as automation, this is something that you have to look out for. Okay, so I think beyond that, I don't want to hold us back too long, before we transit to our speakers. But I want to touch a bit on the studying opportunities that we have so far, because that since everything has been moved online, there has been a lot more studying opportunities, especially if you are looking at getting certifications for Google Cloud. So let's jump into the latest event that just happened recently. So we had Cloud on Board that just happened 2 to 3 days ago. Essentially, you could go to this link over here to see those same sessions on demand right now. But I think one very, okay, so this is exactly the same thing as well for October 27, 28. You can rewatch the program. But the important part, I'm just going to skip this and go ahead, which is the quick labs. So if you like quick labs, you like earning those badges, there's also things to learn along with this campaign that they're running. So you can actually go and try out this quick labs games over here. It's actually only until November the 4th. Okay, I think in Singapore time, they actually over here you can see that in my browser it renders at 5th of November. Okay, so do try this out if you're really interested in learning about some of this technologies in Google Cloud. Okay. Okay, so let me skip this. Okay, and for Quick Labs, they're also running this thing called Work and Play right now. This is more related to in the United States, where it's kind of like modeling over how a company has managed to move their operations to the cloud, and more related to the agriculture industry. So you can also look into this link over here and gain a better understanding of different labs that indicate how they move their operations over. Okay, so this is again in the glossary, so I don't want to hang on this for too long. Firebase, so if you're interested in Firebase, this is not so much Google Cloud, but some parts of it, I mean, if you know that if you create a project in Firebase, there's also a link to your Google Cloud project. And very much so, if you are interested in some of the technologies in Firebase, do check this summit out. This also happened around 2 to 3 days ago. Okay, so I'm going to just jump through this. There's some badges to earn along the way. They have this thing called Pathways, similar to like Quick Labs badges, but or like the labs that you do for getting Quick Labs badges. But in this case, this is actually a beta version of a developer profile that they are creating, separate away from Quick Labs. But if you like gamification, this is definitely something up your alley. Okay, another one is Google Cloud Game Day. So Google Cloud Game Day, this is actually starting next week. So next week, there's going to be, you can see over here, starting at November the 5th, next Thursday, which is where they will actually run this this sort of lab questing, where you'll be able, so it's actually not released yet, I'm not able to see some of the contents, but around this date, they'll open it, and if you participate in that, apparently you'll be able to win a Visa gift card. Yeah, so if you're interested in learning about Apache Kafka, you can check this out as well. Okay, and last thing, okay, so this is something that came out recently, really, really important for those who want to have, who are aspiring for professional cloud certifications. Okay, so there's going to be a 1 month free access to Coursera courses for some of the professional certification. So if you're interested in doing that, in going through the examination in the next 1 month, this is something that definitely I would recommend you to check out, on top of all the other studying materials. Okay, and yeah, multitude of different courses, so do check this out. Okay, so we're running a bit behind time, so I'm gonna just jump ahead of this and let's go directly to our speakers. Okay, let me go over here. Right. Okay, so I hope so far you guys have enjoyed some of the materials we have shared with you. And let's go into the main portion of our our main team today. We want to hear from our speakers the different learnings that they had over time. And so let me go to our program today. We're going to have 3 exciting speakers talking about different topics. Starting off, we'll have Albert, who will be speaking with us about setting up CI/CD with Cloud Build in conjunction with App Engine and Cloud Functions. And then we have a really exciting topic. Okay, sorry, this is a copy and pasting error here, but it's going to be about deploying with Google Sheets. Okay, and lastly, we have Akilesh, who's going to be talking about BQ and TensorFlow. Okay, so without further ado, let's invite our first speaker. So I'm going to bring Albert in. Give me one moment.
Hi.
Hey,
Hi, Ryan. Hi, everyone.
Okay, so I'm going to shift over to your slides.
Okay.
All right. All right, so the floor is yours. Take it away.
Thank you, Ryan. Hi, everybody. So today we're going to be talking about Cloud Build, going from 0 to CI/CD in 30 minutes, right? I don't usually prepare very good slides, but what I like to do is really get in and do get my hands dirty and show you a demo from the very beginning, so you can really imagine how easy it is and how simple it is. Well, there are many steps, but once you follow them, it's simple to get from nothing to have a CI/CD pipeline from your repository like GitHub all the way to App Engine. So let's get started. Okay, so first thing over here, I have the Google Cloud Console opened up. So the first thing we're going to do is we're going to create a project. So we do that by going here and we say new project, and let's give it a name, right? Like DevFest. Well, I already used it a while ago for practice, but let's do SG DevFest 2020. All right, we got that name. Let's create it. And now it's going to create that project. While that's creating, let's also create a GitHub repository, which we're going to use. So let's go to GitHub. And I have my account here. Let's create a new repository. Let me zoom that in a bit so you can see it. And then let's give it a name of SG DevFest 2020. There you go. That's available. That's great. Let's add a README. That's fine. I get ignored. Let's use Node for this one. Doesn't really matter. And let's create a repository. Okay, so let's check out our. So we have created that. Now we're going to clone that. So let's go clone it ahead locally. Let's copy that. Let's go to my iTerm here. Git clone, paste that. Now we're cloning from GitHub into our local repository. We have our file over here. Let's open it in VS Code. And okay, we have our git ignore and our README, which is pretty much our boilerplate. So our starting point. Now, before we continue, let's double check how our project creation is going. And so we've created a project. So let's select the project. And we now have SG DevFest 2020 in our Cloud Console. So that's good. Let's go back to our repo. And what we want to do here is we want to create an App Engine application, just a hello world one, and we want to deploy it. So what I have here is let's open this one. Okay, I have here some App Engine Node boilerplate. So let's copy that. Let's put it in here, SG DevFest 2020. Let's save that. And let's check. Going back. We now have these files. The most important part here is the app.js, which says hello world. And then it's listening to the port provided by App Engine. So this shows up in App Engine. So let's actually test out deploying that. Let's open a terminal. And let's deploy this to App Engine. So we type gcloud app deploy. That's the command. App.yaml. Let's check our app.yaml. Okay, so that's good to go. And then let's just define our project here is SG DevFest 2020. Let's hit enter, and that should deploy to App Engine. Okay, wait. Well, we have to have some options to choose from here because it's our first one. Let's pick Asia East 2. Okay. And now it's creating the App Engine application in project, SG DevFest 2020, in the Asia East 2 region. In the meantime, let me play some background music so I don't sound dull over here. There we go. Do I want to continue? Yes, I want to continue. All right. It's uploading it. updating the service. This takes about a minute or two. Takes a little bit longer than the first time, but you should see it in a bit. By the way, during these lull moments, you can ask me questions. I'm happy to answer questions during these times. Otherwise, let's just observe as this gets deployed. So usually when I'm on stage, what I do is, while waiting for deployment like this, is I usually do like push-ups, right? Instead of like browsing Facebook and stuff. But I'm doing a live stream now, so I just get to sit down, face the music, and watch this together. Okay. Takes longer when you're on live stream. All right, let's just wait for this. By the way, if you're curious of how this looks like, let me show you how this looks like. Let's open our, I turn back here. Where's our edit? Okay, if I were to run this, I would just say npm start. And let me, oops, I have to run npm install first. I'm conquering the spirit, I'm busting through the ceiling. Okay. Anyways, we don't need to look at it here locally because we already have it live. So this is the URL that we can go to. Let's visit it. And hello world. All right, there we go. Let me zoom that in. So hello world. So we now have hello world. We deployed to App Engine. We now have our app online. That's great. Now what we need to do is to set up Cloud Build so that this becomes automatic, right? What we want to do is whenever we push to GitHub, let me show to you how we want it to look like. What we want to do is whenever we push to GitHub, then Cloud Build detects that and then pushes the changes to App Engine and deploys the app basically to App Engine with the updated changes. So let's go ahead and do that. So in order to do this, what we do is we go to Google and we say, Google Cloud Build App Engine, Google Cloud Build App Engine. So deploy to App Engine. There you go. Click that. And let's just follow the documentation because it's there. I really like to just use the documentation because then everybody who can, you can do this again when you access the documentation. So let's go over here. And first thing we need to do is create a Cloud Build configuration file called cloudbuild.yaml. So let's go ahead and do that. Cloudbuild.yaml code. Okay. Save that as cloudbuild.yaml. There you go. Next, where's my, there you go. Next is we copy this. So what this does is this actually simulates the command gcloud because you have this. This is the gcloud builder. So it will simulate gcloud. Then the arguments will be app deploy. So gcloud app deploy. We don't need to specify the project anymore because it will deploy by default to the same project where gcloud Cloud Build is running. And then we set a timeout of roughly, that's a lot of seconds. So that's fine. So we save this. That's the first step. We go back. Let me. Yeah, okay, there we go. Next is we then, we can then push this now actually. So let's do that. So let's go back to VS Code over here, save that, and we say git status. It's bigger. So we modified our README and all these other files. So let's add them. Git add everything. Then git commit -m. What our initial commit. Perfect commit message. then git push origin main. Wow, we're using main now. This used to be master, but GitHub changed everything from master to main. So now it's git push origin main. Okay, so we pushed that, and let's double check our, let me close this so that I don't make a mistake. So we now go back to our GitHub, and we now have the repo over here. Hi, mommy, I'm giving a live stream. So yeah, sorry about that. Just had to tell my mom that I'm giving a live stream. Okay, so this is our repo now, and it's here, all the files. But how do we get this from here to App Engine, which is SG DevFest 2020? How do we get it from here to here? So what we do is we go to Cloud Build. So we go over here and say Cloud Build, Cloud Build. Again, Cloud Build. Okay, now we're at Cloud Build, and what we want to do is create a trigger. So a trigger is what will be watching our repository, GitHub in this case. And whenever there's a trigger, like a push to a branch, push to a specific branch, a pull request, then it will trigger a build. So first we have to connect our repository. So we go ahead and do that. We choose GitHub because we are on GitHub. We can also choose Bitbucket if you want that, but I'll choose GitHub. And then I'll go through an authentication process, which I've already done. So I've skipped that whole process, but you can go ahead and do that if you haven't yet. So let's go over here and let's type SG DevFest. There you go. This is our repository, which is over here. And then let's check the I understand really long message over here. Let's connect that repository. And we'll skip for now because I will create a trigger manually. Okay. So skip for now. Yes, skip. And then we're going to create the trigger, and we're going to define that as deploy main, okay, which will push to a branch. Which branch? Well, this repository and the main branch. So Google hasn't changed it to main yet. It's still master, so we have to manually change this to main. There you go, and it matches the branch main. And then our Cloud Build configuration file is cloudbuild.yaml. That's correct. And let's create that. So now we have a trigger that watches the main branch, changes or pushes to this branch, will then run cloudbuild.yaml. And cloudbuild.yaml is basically this file, which runs the command gcloud app deploy, in this case, app deploy. So that's great. Let's test it out. And the way we test this out is by actually making a change and pushing to our repository. So let's go ahead and do that. So instead of saying hello world, let's say hello GDG Singapore. And let's add a couple of exclamation points there to prove that we're happy. Let's add also a woohoo. Okay, we have to double. Do we have to? No, I don't think so. Well, anyway, we'll find out if that works. Let's save that, and then let's push this. Git add everything, git commit -m, better hello message. And let's push this. Okay, let's watch this as it happens. Let's go to Cloud Build. Okay, let's go to history. And we only have one build here, which is a previous build. What should happen now is that anytime now, there should be a build. And there you go. Woohoo! Boom. There it is. We can click it to watch the progress, right? And then it failed. Oh my, it failed. What do we do now? What do we do? Well, we go down and look at the logs. So it says here, user Cloud Build has no permission to access, or it may be App Engine admin API has not been used. So this is because we didn't follow the instructions above over here before you begin. We didn't enable the App Engine API. We should have done that. Anyways, Albert, follow instructions next time. But I actually did that on purpose so that you can see that when there are errors, you can actually see it in the logs. So there we go. Let's enable this by clicking this. Well, let's copy paste it then. Copy paste that. And we will enable the admin API. Come on. Press enable. Okay, while that's enabling, let's do the second part, which is, here we go. Let's look for the second instruction, which is cloud build settings page. Let's go ahead and click that. And then we have to set both the status of App Engine admin and the service account user role to enabled. So this one over here, this is actually just the same page as Cloud Builder. If you go to Cloud Build, this is actually the settings page over here. So anyway, settings, and then let's go to App Engine, enable, and then also the service account user, enable. Okay, now we've done both instructions, this one and this one. Let's double check our App Engine admin API if it's already done. Well, it's not yet done, but okay, I think it just finished. Great. So we can now close this. Let's refresh this. This is still hello world. Yep, it's still hello world. Now let's go back over here to our triggers. Let's close the other one so we don't make mistakes. Deploy main. What we can do is we can run this again, right? We can either do two things. Once we can push to the repo a change, so it will trigger it, or we can just manually press run and run it. So let's go ahead and press run. Okay, actually, not that. Let's go to history. We can do that actually, but what I wanted to show was actually this, and then we press retry. Let's go ahead and retry it. Okay, so again, it's now building, and it's now fetching the changes from our repository, which contain our hello GDG Singapore with multiple exclamation points, and now it's deploying that. So no error messages this time so far. Fingers crossed. Let's see if this completes. All right, in the meantime, again, some music. Do you have any questions? Now is the time to show them. Now is the time to type them in the comments so I can answer them. So again, actually while waiting, why don't I show you around what this other parts of Cloud Build is. So we go to the dashboard. So in the dashboard, this shows you like all the triggers that you have, if the current trigger is running, and the durations over there, the source, the repository, and the commit ID that is being run right now. So it just showed us that it's already succeeded, but it also gives you some other information of average duration and then the pass-fail sort of statistics. So now that it's done, why don't we actually go over here and refresh this? Moment of truth. Hello, GDG Singapore. Oh yeah, it doesn't show up. It's a special character, the backslash. We should have done a double backslash. Anyways, we have hello, GDG Singapore. Awesome. We did not have to manually deploy this. All we had to do was push to main branch. All right, push to main branch in our GitHub repository. So actually, if we go over here and we change it over here, like for example, let's edit this one. We don't have to go anymore to our repository, to our local. We can just say that this is pretty bad practice, but I'm just gonna do it anyway. And we save that, and this should automatically trigger. A build. So there it is. It's building again. So as you can see, we now have a continuous integration, continuous deployment pipeline setup, just like that. And we just follow these instructions. We put in the cloud build.yaml, and then we set up the trigger. We went over here and set up the trigger, and we connected our repository and set up the trigger. Okay, now while that's deploying, what I want to do next is actually say, like, what if you're not the only one, working on that repository? What if there are multiple people that are working on this repository? Or what if you want to create a branch and then deploy that branch instead, right? Now, this works really nicely with App Engine because let me show you this. App Engine is something called versions. So let me go over here and then open App Engine. App Engine has this feature called versions, where you can have different versions of your code deployed into App Engine, and they all run on separate URLs and can be accessed separately. So for example, we go over here, App Engine versions, and right now, what's serving is this version. This is the Hello GDG Singapore, and I think it will transfer to this shortly because this is being deployed. This is the Hello App Engine, no, Hello Singapore, GDG Singapore, with the correct, what do you call that? ASCII art. I don't know if it's ASCII art, but with the correct, with the double backslash, basically. So each version over here can be accessed by their own URL. So for example, let's go to this previous version. Let's go click it. And as you can see, we have this special URL over here, and it says Hello World, right? This is a previous version of our application. And we access it by using this convention. We have SG DevFest 2020.df.r.appspot.com. But before that, we have this word dot, which is -dot dash, and then the version name or the version ID, right? So we can access specific versions in App Engine using that. Now, this is really handy. This is useful because what we can do is we can say, hey, Cloud Build, why not every time I push to a branch, deploy a version, a specific version of with the same branch name and deploy it to App Engine, but don't promote it. Don't make it the default version so that it doesn't appear on the default URL, which is this. So this one is now Hello GDG Singapore with, yeah, we got that right, yay. But this one is still Hello World. So why don't we try that out? Okay, what I'm going to do is I'm going to go back here and I'm going to create, I'm going to change this. I'm going to add some background. I make body style equals background color yellow. Yeah, let's give it a yellow background, really bright and yellow. And then slash, well, actually, before we do that, let's actually fetch first our changes. Git fetch, because we change it in GitHub directly, so we have to fetch the changes. Git rebase origin name. Okay. Okay, let me close that. So, okay, open it again. Okay, so now let's add the background. So background body style equals background color. Let's give it yellow, and then let's close that. Whoa, sorry, I made it too small. Wrong key press. Okay, and then let's close the tag here with slash body. Okay, that's not how you're supposed to do things in HTML and Node.js Express, but for this example, we're not demoing Node or Express. What we're demoing is Cloud Build and automatic deployments. So we have that. Let's just double check. Background color is yellow. Great. So let's check out the branch. Git checkout -b. Let's call it yellow background. Okay. And let's git add app.js. We don't have any bugs in here. Okay, we will find out. Then git commit -m, yellow background, and let's git push. Okay, let's do that. Okay, so now we're pushing a yellow background, but nothing is gonna happen actually in here. Nothing's gonna happen. Let's go to Cloud Build. Let's go to Cloud Build, triggers. Let's go to history. And as you can see, nothing has happened here because we don't have a trigger for this. We only have a trigger for the main branch, right? Deploy main. So what we're going to do is we're going to create a trigger that says deploy branch, okay? And then we say push to a branch, but we give it we say main over here, but then we say invert the regex so it matches any branch that is not main, okay? So in this case, it matches the branch yellow background and all the other branches we might create. So we then, we have to create a Cloud Build configuration file. This one, we want to create, we want to have a separate Cloud Build for this, or else it will deploy the version anyway. So what we'll do is we'll do Cloud Build dash branch. Let's create that. Okay. So now we still lack one thing, which is putting the cloud build dash branch. So let's copy this and let's save this as cloud build dash branch.yaml. Let's save that. We say gcloud app deploy. Now the command for deploying a branch is dash dash version equals then the branch name, right? So what we will do is we'll add it here. Dash dash version equals dollar branch underscore name. Now this dollar branch underscore name is actually a special variable. It's called a substitution variable that is in Cloud Build that you can access. You can also access other things like the repository, the commit ID, the commit hash, and other stuff. There's a list for this. I'll show you in a bit after after I push this. So gcloud app deploy version branch name. And then we also want to add one more thing, no promote. Okay? We want to add no promote so that it won't promote it to the main version, to the default version. We want to keep this as a version that's deployed, but not yet accessible via the main default domain. So let's add that, dash dash no promote. Save that, and let's push. Git status. Okay, git add, git commit, -m, add cloud build, branch, and git push. Okay, so now it's pushing. Let's see if it triggers our trigger. Let's go to history. Okay, so now that's working, and it's doing the yellow background branch. Let's check it out. Make sure that all things okay. So while this is building, let's read about cloud build substitutions. Here we go. So these are the list of variables that we can substitute in cloud build. Let me zoom into that. Okay, so these are the default substitutions. So your project ID, which is the ID of your cloud project, build ID, that's for build, and then the commit SHA, the revision ID, the short SHA, the repo name, and the branch name, which is what we are currently using. You can also use tag name so that you can use it somewhere in your cloud build YAML if you want. Okay. These are also GitHub specific ones, so they're not available in Bitbucket. But if you're using GitHub integration, then these are also available. All right, there's some more info there. You can just Google it. Meanwhile, let's check it out. Okay, it's still deploying. So check out our App Engine versions. Let's refresh this. And as you can see, we're still default serving this one, right? So let's go over here. Let's refresh this. So by default, this is still showing. It hasn't become a yellow background. So that's good because that's what I want to do. But let's check our newly deployed branch. In this case, what's our newly deployed branch? Let's refresh this. Its name is yellow background. So let's see over here. We can take the same URL and put it there. And then let's add yellow dash background. Background dash dot dash SG DevFest. And then this should go to our specific version. Let's hit enter. And ta-da! Wow, that's bright. That's really bright. Okay, so we now have the yellow background in this URL, but in our main URL, it's still this the one in main. So what can we do with this? How is this useful? Well, what you can do is you can push to specific branches, and then it automatically gets deployed to Google Cloud Build, right? So, for example, we go ahead and merge this. Let's go ahead and merge this. And so let's say we test it and we say like, okay, QA approves. We send this to our client and say, okay, the client approves. We can now ship it to production, all right? Put it to the main, show it to all the users. So then what we can do is go ahead over here and make a pull request. How do you create pull requests? Pull requests. So I usually use Bitbucket. So new pull request. Okay, I hope I can figure this out. Yellow background. Okay, there you go. Create pull request, and then create pull request. And then let's merge it. Okay, now that it's merged, it should trigger a build again. All of this automatic, right? It's triggering a build on main. So yeah, there you go. That's basically how we do App Engine and Cloud Build deployments automatically using Cloud Build, pulling from the GitHub repository, which can be Bitbucket, or it can even be Cloud Source repository in Google Cloud. Cloud Build is monitoring it using triggers that you can configure, and then it then automatically deploys it when the triggers are triggered to App Engine. So now you don't even have to deploy locally. You can give somebody access to your GitHub repository. They can push to a branch, and automatically they can have a test URL like this one. So for example, let me show you one more time, right? Like, what if we want to make this blue background instead? So let's go git checkout main, git fetch, git rebase origin main. I'll git checkout blue. Let's just call it blue. Oh no, git checkout minus b blue. Okay, so now we have blue. Let's go back to app.js. Instead of background yellow, we say blue. We save that, and then git add everything, git commit blue version. I just want to play around. Git push. Okay, we have to do this. And then let's watch our cloud build. So this one is now building blue automatically. We don't have to watch it actually. We just have to wait, right? We can just say blue. This is still yellow. Why is it still yellow? Because blue is not yet deployed. When blue is not yet deployed, it defaults to show the main version, which in this case, what's the main version? The main version is now this, which actually contains the yellow background because we merged it into main. Okay, so let's wait a little bit for blue to be deployed. Okay, while waiting for blue to be deployed, I want to show you actually this cool feature in App Engine called traffic allocation. So you can actually do traffic splitting over here. So you can like check and check over here with different versions and say, I want to split traffic, right? To split traffic randomly and show them different versions like percentage. So by accessing the main URL, people might will end up on different versions of the applications. This is useful for A/B testing, for rolling out a new version that you're not yet sure if the error rate will be high. You can do this thing, right? Anyway, let's see if the blue version has already been deployed. So it is already been deployed. So let's refresh this one. So there you go. It's now blue. But going back here, it's still yellow, the main URL. All right, so what have we done? Let's go back to our main presentation. What have we done? We've integrated App Engine with Cloud Build by connecting GitHub, Cloud Build, and App Engine. It's simple and it's straightforward. We've also used a custom Cloud Build YAML for our branch deployments, so that whenever a branch is deployed to, a branch is pushed to GitHub, then we use a custom Cloud Build branch to deploy just the branch name to App Engine, so we can have some sort of testing environment for our branches. Okay, now let's go to Cloud Build and Cloud Functions. All right, so Cloud Build and Cloud Functions, we're gonna do the same thing we did with App Engine, but instead of App Engine, Cloud will deploy to Cloud Functions. So exactly the same chart, except exactly the same flow chart, but with Cloud Functions at the very end. So let's go ahead and do that. Okay, We will reuse the existing project this time. So let's go back here. We'll use the same project, but we're going to create a new repository. So let's go over here in my GitHub. Let me zoom out a little bit because it's a bit too big for me. Let's create a new repository. And let's say SG DevFest functions or function. Okay. Add a README, fine. And then let's put node here. Again, it's just anything. It's just a plain repository. Let's create a repository and let's clone it. Copy it, iterm, git clone. Okay, so now that we have the DevFest function, let's create a function. So cd sg DevFest function. Open that. Okay, so how do we create a cloud function? That's really simple. You just go to Google and you type Node.js cloud functions. Then your first function, let's copy that. Let's click that. Oh, okay. So let's go do these things, create a function, and let's copy this. Okay, let's copy that. Actually, what we can also do is run npm init here. Let's just run npm init. Npm init. Yeah, let's do all of that. Just go into defaults everywhere. Yes, that's okay. Okay, and then we create a new file. Save that. We call this index.js. Okay, so index.html requires escape HTML, but we're not going to do that. We're just going to make this a straightforward hello HTTP. Let's call this hello SG. Hello GDG SG. There. Hello, let's remove all these other things. Let's make this hello GDG Singapore. There you go, save that. Hello GDG SG. Okay, so far. Okay, now how do we deploy this? Well, we go over here and we ask Google again. What do we do, Google? Okay, we don't want dependencies because I removed that. I just deploy this function. So let's copy this. Okay, let's paste it. G Cloud functions deploy. The name is not hello HTTP. HTTP, the name is hello GDG SG. And then runtime is node, trigger HTTP, allow and authenticate. And then I'm going to specify the project. Project equals SG. What's our project? What's our project? Our project is this one, SG DevFest 2020. Okay, let me copy that. Okay, SG DevFest 2020. Let's deploy that. Would you like to enable and retry? This will take a few minutes. Yes, enable the Cloud Functions API. All right, so while that's enabling, let's play some music again in the background. Wow, that's some really high-speed music. Wow, this makes deploying Cloud Functions super exciting. All right, it's now still deploying. Okay, it may take a while, up to 2 minutes. Anyways, we'll be patient. Oh, we can multitask on this one. Let me mute the music. Let's multitask again. All right, so for this one, while we're waiting for that, let's go forward and actually set up the cloud build integration. Okay, so we need a cloud build.yaml file for that. So let's save a new file. It's called cloudbuild.yaml. Save that. And then what we then do is, let me find my sheet. Okay, we just copy the same thing from the previous one. Where's SG DevFest 2020? That's good for cloud build. Let's copy this. Okay, save that. But instead of running gcloud app deploy, we want to say gcloud. That's the function. What's that function? Where's that? Okay, this one. I want to say this instead. So we want to say that, right? So let's allow word wrap. Okay, so G Cloud, we copy this, functions, deploy. Okay, that's correct already. Then we add hello GDG SG. Then we add runtime. Just copy it all over here. Node.js 12. Oops, let's add, make sure it's there. Then trigger HTTP. Okay, and then we then say allow unauthenticated, and we should be good to go. All right, we save that. That's a cloud.yaml. Okay, and then let's see. Actually, okay, so let's hold that thought. Let's park that. We just created our cloud.yaml file because we have breaking news. Just in, we have our cloud build function. Our cloud functions. And what's the URL? Okay, the URL is this. Let's visit this one. Copy that. No, I just want to copy it because I'm going to go to it manually over here. And it says, hello, GDG Singapore. Very cool. Okay, now we have our cloud build. And what we want to do next is we want to test that if we make a push to our repository, it should automatically deploy to Cloud Functions. So it should update this. So, okay, things on our checklist. First thing, we have a repo. Okay, we have a repo. Okay, that's already there. Next, we need to make the trigger. So let's go ahead and, well, we haven't pushed it actually. So let's push it first here. Well, we can push it later so that we can do it in one go. So we'll make the trigger first. So let's go to cloud build, and let's go to triggers. We're gonna create a trigger. Before we create a trigger, we have to connect our repository because it's a separate repository. So let's connect our repository. Let's connect it. And let's go to SG DevFest function. And then let's click I understand. Of course, I understand. I always understand. And we'll skip that because we'll create a manual trigger over here manually. Create a trigger. We say deploy function. Hello SG. And then we say push to a branch, push to any branch, yeah. And then SG DevFest function. We want the main branch. Okay, and then cloud build at configuration, cloud build at YAML, and let's create that. Okay, so now just time to push. So let's go back to history. Let's see, nothing has happened here. Okay, so now let's just verify. We have our cloud build at YAML. So now it's time to push. Git status. Git add everything. Git commit -m initial commit. And git push. Okay. It's now pushing. Let's check our GitHub if it's there. Okay, it's over here. All right. Now let's check our cloud build. Now it's deploying. I think there might be some errors here. Okay, we do have an error because we don't have the permission. So what we have to do is go back to settings, and we're going to enable cloud functions. Okay, this is all documented. We don't need to do this because we've already done that. This is all documented in deploying a cloud build function, cloud functions. So go to Google, and then you have the documentation here. This is just what we're going through again. Okay, so yeah, see, enable the cloud functions API, which we've already done. We open the cloud build settings as well, and then we cloud functions developer role to enable, which we have just done. So let's go ahead and rerun our build. Retry, see if that works. Okay, so far so good. Okay, while we're waiting for that to build, is this a failure? It's just a warning. Okay, so while we're waiting for this to build, let's create our next set of change that we want to automatically deploy. So instead, let's add our favorite ASCII art, which is the, okay, we have to do a double thing again. Okay, we save that, then terminal. Okay, and let's push this. Status, git commit, git add, git commit -m, add that, git push. All right, let's see first if the previous one has already been deployed. That hasn't been deployed yet. So it's still deploying. Okay, just finished. But nothing actually, no, that's not. This is App Engine. Let's close those so that we don't get confused. All right. If we refresh this, it's still the same because our change is actually in the new push. So if we go to history, yeah, this one. This is the new build that's been triggered just 18 seconds ago. And we should see it soon. But for now, it's just there. So yeah, how this is also useful for when you have repositories that are just very small, like this one. We just want to create this function that says hello world. So we create a function. We don't need to deploy it to App Engine, though we could. But it's less code with just a cloud function. So literally, we only have this piece of code, and that's it. Just a few lines, and you can immediately deploy it to cloud functions, integrate with Cloud Build. So you forget about the whole deployment thing. You can then just use GitHub. You know, people will then clone it. People will push to a branch, and people make a pull request. And whenever you merge the pull request to main, it automatically gets deployed. So that's pretty cool for me. Like the more I can forget about actually having to deploy things, the better. That's the whole purpose of having a CI/CD, and we can use this with Cloud Build. So there, it's just finished. And now, moment of truth. If we refresh this, is this already updated? And oh no, there you go, refreshed, and boom, we have our ASCII art. Woohoo! Okay, so yep, I think that's it. We've done App Engine and functions integrated with Cloud Build and GitHub to create a CI/CD, 0 to CI/CD in just 30 minutes. I said 30 minutes, right? But I took about 60 minutes, I think. So, but anyways, let's connect. My LinkedIn, you can search me, Albert Padin. I'm also on Facebook. Just message me. Say like, you heard about me because of GDG DevFest Singapore. Then I'd be happy to connect. You can also email me at albert@symph.co, which is the company that we do. We build websites, mobile apps, web apps as well, mostly on Google Cloud. If not, actually, mostly in Google Cloud. So yeah, that's our specialty. Anyways, I'm now open for questions. Thank you, everybody.
Hey, Albert, thanks a lot for that very insightful.
Wait, and I can't hear you.
Oh, wait.
I don't know.
Can you hear me?
I can't hear you. I don't know if it's just me, but I can't hear you. There.
Does it work now?
Yeah.
Okay, awesome. Okay, so yeah, as I was saying, thanks for the very insightful sharing. Let's go through some questions. All right, so I'm going to bring up one from Hairizuan. So he's asking about, I think this is related to Cloud Build. I mean, because some of the options in Cloud Build, I think you can improve Bitbucket and GitHub. How about GitLab?
Yeah. So I don't know actually. I haven't used it. So I'm gonna type Cloud Build, GitLab. Let's see if there is something there, right? So yeah, there is this option to mirror cloud source repositories. So what you can do is you can mirror your GitLab repo to cloud source repository and then run the trigger against your cloud source repo. So it's a one-time thing that you have to do, but then after you set it up, it's pretty much the same thing as what I just showed you. So the answer is yes, you can use Cloud Build by mirroring it to cloud source repository.
Since we're on the topic of mirroring, so I actually asked this question because I was curious. I think mainly I've been using the mirroring option for GitHub repositories to cloud source repositories. This is specifically for GitHub. But in the case, so I realized that you are using the GitHub app, right?
Yeah.
Is there a difference between these two options?
Yes, yes. So there's a slight difference in that the GitHub app has a two-way thing, two-way communication with your GitHub repo, right? The mirroring option is that it's just Google Cloud Build listening to the repo and saying like, if there's a push, then I get a trigger. However, with the GitHub app, which I didn't show anything about it, but Cloud Build can actually send sort of, make a push, update the pull request, and say that this is the URL for the finished build, right? Like there's a two-way now communication between Cloud Build and GitHub in the sense that Cloud Build can now respond to GitHub triggers. So
Wow.
that's the sort of like one of the main things that I've seen.
So if for things like, let's say within part of the CI/CD pipeline, if you have maybe you're running some test and the test fail, you could send this as some notification back to the pull request?
Yes.
Wow, that's awesome. Okay. Another question from Hairizuan. So he's asking, can I use tools like Ansible that relies on SSH to deploy applications to virtual machines? That's Cloud Build support the shelling capabilities.
Yeah, so the way this is done is, okay, let me Cloud Build. So the way Cloud Build works is it actually runs a Docker image, and it runs the commands inside the Docker image. So let me show you. For example, Cloud Builder's Cloud. This is running the Cloud Docker image, and then runs these commands inside that Docker image. It's in the sense now Docker container to deploy the app. So what you can do is you can go super custom actually and have your own Docker image. That in that case you can have like Ansible, right? Like an Ansible Docker image, and you put it in here. Let's see if Cloud Build actually has Ansible here. Ansible. I don't see Ansible, but there is a supported builders complete list. So let's see. Ansible. No, I don't see Ansible here, but alternative official images. I have a feeling that there is a way to do everything because this is just Docker images that you can, if you can put Ansible in a Docker image and then run that, then you could do that. So I'm not 100% sure because I don't see it here right now, but in my mind, like I'm pretty sure it can be done.
I think for native shelling, definitely possible, right? Or even if you need to use the G Cloud CLI to run some operation for VMs.
Yeah. I'm not actually 100% sure, but I could look into it. You could look into it, but I'm not 100% sure of that SSH capability. But I have a feeling it can be done.
Yeah. Okay, let's maybe go to a different question. Ooh, another one by Hairizuan. Let me move my face. Okay.
Sure.
So he's asking if you have a very complex Cloud Build configuration, does Cloud Build support the capability to start in the middle? So I'm guessing he's referring to parallel as well as series mixing, a mixture of the stages.
I haven't tried that actually. Yeah, that's interesting. I haven't. No, I haven't tried that. So I don't know.
Yeah. Actually, I've not seen this before. I think.
But I don't even know if are there CI/CD pipelines that actually allow you to do this.
I guess that's more of like, what's the equivalent tool in GCP for this? I might be getting a name wrong. Data prep, is it? Is that the name? Like something like that where you have multiple stages and you're running a task, but it's not a CI/CD pipeline.
Oh, so, no, that one's a data flow.
Data flow.
It's not a CI/CD pipeline, but yeah, this is interesting for me. I guess I have not really had a very complex build configuration yet. I hope I don't get to that.
Yeah. I guess for all the CI/CD pipelines, usually, maybe the providers also don't provide that, maybe because usually you want to do this on a per commit level or maybe when you're opening PRs. So sometimes it happens so often that you don't even want to monitor it per pipeline. You just want to know like each pipeline what happens. But it does bring a very interesting question. Yeah. Okay, maybe let's go to a different one. I think this is quite interesting. So this is more in terms of cleaning up versions. Like just now you demonstrate the different versions in App Engine.
Okay, okay.
Hmm.
Yes. Yes. So App Engine, App Engine doesn't delete it at all, right? So I think you for paid applications you can have up to 200 something, I think,
Wow.
app versions running at the same time. Um, so what we do is we built like a custom like cron that looks up like how many so it runs gcloud where you can list all the versions and you can count the versions, and then if I have more than 150 versions, we just pick a number, right? And then we delete the previous like the after 150 older versions, so we always have the most recent 150 versions. Anyway, it's for free as long as you're not running instances, you're not being charged in App Engine. So for the 150 versions and more, like we prune them by deleting them using this automated cron that we built. However, you can also do this manually, right? Like when Cloud Build runs and then the versions, and then suddenly Cloud Build fails and it'll say error, too many versions, and then so you can go in there and manually delete them. So, but what we've done is, since we do it very often, is we've done a custom cron running on a compute engine somewhere, that basically like logs into G Cloud, checks out the versions, and constantly just prunes it every day.
That sounds really awesome. I also have this problem as well, and I've thought about automation. I think it's really inspiring to hear that, yeah, set up a cron job, use that, just clean up the older ones, anything more than 150. Yeah, I think that sounds to be a pretty sound solution.
Yeah.
Okay, let's do one last question. So I think this is mirroring towards App Engine. This
Uh,
function has a versioning.
so let me double check. I have a feeling yes, but I'm not 100% sure. So functions, let me see functions. I could just actually Google that, but let's see. Cloud functions. I have a feeling that, because I know Cloud Run does. So it's almost like there's App Engine, Cloud Functions. Let's see. No, it doesn't. Here, it has a version 3 deployed, right? But I don't know of a way of. Maybe it looks like there's a version system because it's version 3, but is there a rollback mechanism? I haven't tried it. Cloud Functions version rollback. I don't know. It looks like there's not. We're already in Stack Overflow now. Yeah, it doesn't seem to be built in. So I would say 90%. Well, there's this thing. So I don't know. So I'm back to I don't know. That's homework for you. Here's one. You get plus points if you figure it out.
And then maybe we'll tweet the answer to you.
Yeah. Yeah. I think not. It doesn't seem obvious at this moment. All right. Do you have another
All right.
question?
So I think, yeah, that's the last question. Yeah, Albert, thanks so much for being with us today, sharing with us as well as our participants in terms of your learnings in using Cloud Build as well as with the serverless options. Thank you very much again.
All right. Thank you, Ian. Thank you, Rizwan. Thank you, everybody. Hope you enjoy that. Bye bye.
See you. Okay. So, well, okay, let me take away that question. And I'm going to share my screen. Give me one moment. Okay. So yeah, let's we have Albert so far who demonstrated to us in regard to serverless with Cloud Build. I think it was a really good sharing. But next up we have a very interesting topic from Hairizuan. In terms of deploying via spreadsheet, what type of madness is this? If I were to say so myself. So yeah, let's bring Hairizuan to the stage. And let's hear what we have. Hey, Hairizuan.
Hello there. Yeah, a bit controversial topic, but yeah. Okay, I guess let me share my screen first. Then after that, I'll get the ball rolling on my side. Let me see. Is it possible to just share? Okay. All right. Looks like I take over the slides. Okay, let me quickly get started. Okay, so deploying via spreadsheet, like what do I mean here? So yeah, I mean like before all that, like first I need to say like hi guys, Hairizuan here, a DevOps engineer from Acronis, and I think one of the GD experts in Singapore. So if you got any like Google Cloud related questions, just ping me. I'll try my best to answer them. But then again, GCP platform moves so fast, so there's no guarantee that I'll be able to help out too much. Yeah, we'll see how it goes. But okay, now back to the topic. So, what do I mean by this deploy via spreadsheet? So, let's take a few steps back and then like think about how this whole thing started. So, if you have played around with Kubernetes all this while, you realize that Kubernetes has a very, very nice way to declare resources, and like Kubernetes has this mechanism to resolve whatever you declare in that resource files to what you want. So like it has a very you just declare what you want. Like maybe you have engines deployment and you want 5 replicas of it. So Kubernetes will look at that as like, okay, I see that you want to have a deployment resource on Kubernetes and you want to have 5 replicas of it, 5 pod replica. So the Kubernetes will just make it happen. So you have this very nice idea where you just declare something and there's a mechanism to kind of resolve it and make whatever you want happen. So you don't have to think about how do you get to 5 pods. Like let's say if you have currently 8 pods, you don't need to think, okay, I need to subtract 3. What if there's a race condition, etc. You don't have to think about that. Essentially, that whole mechanism, declarative mechanism, is kind of widespread nowadays. So this mechanism has been applied to like various other tools. One example is Terraform. So you just declare what you want in like this Terraform file, and like maybe you want a few VMs, and then you use Terraform. You just apply that Terraform to the GCP or other cloud platforms, and you'll make it happen. Like if you want 2 VMs in Google Cloud Engine, and then Terraform, if you Terraform apply, you will get the 2 VMs as you need or as you want. So on top of all this, then you have this movement that quite recently occurred. I think sometime like late last year. It started like gaining some traction and all. There's this movement about GitOps where, let's say if you're a company and you have a whole bunch of applications that you want to deploy, what if you have that capability to like set the required application versions and put it all into some Git repository, and then you have this mechanism that will look at that Git repository and then deploy it based on that Git repository. Now you have this very nice mechanism where you have a versioned way to declare what is inside your data centers, which is very nice. Like it's this whole thing has a very nice way of working. So you just declare something and the mechanism will make it happen. So similar to like Cluster API. Cluster API also something new where you just declare how many Kubernetes cluster you want, what kind of Kubernetes cluster you want, and where you want it, and then this mechanism will somehow make it happen. So where we take this whole mindset or thought process and apply it such that you have a mechanism that listens out to a spreadsheet, and this mechanism will apply the changes to a cluster. So that is what I mean here by deploy via spreadsheet. So I make my changes, but it's not like GitOps where you apply it in a Git repository, but instead I put my data or what I want in a spreadsheet. And since spreadsheet, like kind of everybody in the working world kind of has to use spreadsheet in one way or another sometime in your life. So I guess like it's a possible way to kind of get what you want, and then you have the mechanism that kind of replicates it over to the Kubernetes cluster. Yeah, so it's like why I was mentioning since just now. So why if we take that approach and then instead of listening to Git repository, we listen to a spreadsheet. So so what are the things that kind of required here? So you have this Google spreadsheet that will contain all the data that I want, which is I will declare. The mechanism needs to kind of analyze what's there. It needs to compare it to what's in the cluster, which is to observe it. And then after that, basically resolve those differences and then make the changes required in order to make it happen, to make what your declaration happen. Yeah. So the one, like, I guess like for all those who are viewing this, like the main question is like, why do we want to do this? So, I mean, there's no exactly like commercial reason, though no technical reason. The main thing is because we can. That's one. Secondly is because for me personally, I kind of want to build something that kind of touches a bit on the Kubernetes internals. I'm starting like in my career wise, I'm starting to require to build things that rely on Kubernetes API and kind of want some sort of starter project to kind of get started to learning about how do you build something in a component in a Kubernetes cluster that requires you to talk to Kubernetes API, etc. So I guess it's kind of a stepping stone of sorts to go in there. So that's one of the reasons. And also to kind of prove a point that, building things on top of spreadsheets, not exactly a good idea. So let's get started here. So what will it look like at the end? So at the end, this is what we probably like. Let's say if you were to build this thing, end users that will like deploy stuff in your cluster will only interact with this spreadsheet. And then the rest of the mechanism is kind of hidden away from them. Like once you as a user, you just type in what you want, what image you want to deploy, and how many replicas of it. The mechanism will just look at this configuration and deploy it accordingly. So for those who want to see this and want to follow along, you can look at this GitHub repository. I will share the links sometime later. All these links. I mean, you can also view the YouTube recording like sometime tomorrow, I think. But yeah. So I don't exactly have a demo because my computer isn't strong enough to do a demo and do streaming at the same time. So what I have here is a YouTube video instead. So maybe we'll just watch and I will try to explain what's happening here. So if you clone the repository, essentially what I'm doing here is essentially I'm trying to prove that there's nothing deployed yet in this cluster. So trying to show like, okay, there's no ShitOps controller, the mechanism to help deploy. There's no pods. What I did previously was that I already built it and I already pushed it to Google Cloud Container Registry, and I'll be using the latest version 16. In this code base, let me pause here. If you look at this code base is actually built on top of this framework called Kube Builder. I will later share the link to Kube Builder sometime at the end of this demo of sorts. Yeah, so let us continue. So there's a whole bunch of nice make commands. Later I'll be using a make command to kind of, did I restart? Okay. Yeah, so continuing from just now, essentially I'll be using a make command. There's a bunch of make commands that's kind of like available out of the box if you are using the Kube Builder framework. So I'll be using the version 16, the one that I show here, the version 16 that I already built. Yeah. So this step essentially deploys that mechanism, which is just a Kubernetes controller. or just a like essentially it's just something. Oh, hold on. How do I go back? Hold on. Oh, I think my screen hang. Okay, hold on. Technical difficulties. I think my CPU hit 100% at that moment just now. Let me present again. Okay. Yeah. Hello. Okay. Back to the video. Okay, let me run the thing. Let me go to sometime near the end. Okay. So for this part, what essentially just happened here is the controller component of this, like the mechanism has been deployed to the cluster, but in order for the cluster to talk to all the various Kubernetes API, there's this authentication mechanism called RBAC that we need to kind of configure. If using the Kube Builder framework, there are actually some specific set of instructions to help you do this up much more easily. Then specific instructions, like let's say if you want to alter like the deployment object in this Kubernetes cluster, you need to add a certain command, and then using make commands, you will generate out the required RBAC files, which you can apply to the cluster so that your component, this component that you deployed, that will do this like syncing of spreadsheet configuration to the cluster, will be able to talk to the Kubernetes API. So it's just an off authorization thing that you need to kind of handle. So let us continue. So, okay, just loading. So the next bit is essentially, just making sure that the component is just there. Okay, and all right. My camera just gets stuck once in a while. Okay. So let's go to the next slide. Okay, so so when you're building this Kube Builder, essentially, there's this thing that you will actually be creating. So there's this thing called custom resource definitions. Custom resource definitions are essentially resources that are not natively available on Kubernetes clusters. So so if you see here, if you are like familiar with these Kubernetes definition files, right, you will probably never seen this kind. Usually, kind, it refers to what kind of resource you are trying to alter. Usually, the ones that you usually see will be like deployment, pod, stateful set, etc. So using this Kube Builder, it allows you to kind of create this CRD definition. So in this case, I've told my cluster like, okay, now I have this new type of resource called Google Sheet Sync, and I will be using it to define my configurations, and then I expect you to kind of manage it for me. So this is what the Kube Builder framework kind of provides for you, and then you can kind of use it to do up this integration. Okay, so for those who are not too familiar with what this custom resource do, what you essentially do is you create this controller, or like this component, this mechanism of sorts. This mechanism, if you look out in the Google and everything, usually they have this thing called the operator pattern. So essentially, the operator pattern is essentially just like you have this new custom resource that you are trying to manage, and this component will operate based on that resource. So that is kind of the whole thing about operator pattern. It's nothing too complex of sorts. So if for those who are kind of interested in that, just find operator pattern Kubernetes, and then you'll find a large amount of documentation about it. So hopefully this goes well. Yeah, let me play the YouTube video. I'll try not to disturb it too much. So for this section, what I'm trying to do is I'm trying to deploy it based on the spreadsheet. Okay, let me try to increase to HD so that it's clearer. So back to the start. So I have this configuration where I'll be deploying engines with 4 replicas. And then you have this CRD that I'll be applying. So remember just now I already applied the controller. So that means the next step I want to do is to apply that CRD to the cluster. So if I do this command to apply it, you will see here it's just keep a simple apply command. Then here's I'm showing like what's the definition of it. So this I will be querying this new resource kubectl get Google Sheet sync sample, Google Sheet sync, and the name of the resource is Google Sheet sync sample. So from that, just now I was mentioning that I have a LOL deployment that will be deploying 4 pods of engines. So I didn't have time to go and to check that whole thing is working. Like essentially, like it's already there the moment I done querying my resource that makes sure that's there. So the next step is to make sure that the pods actually is running engines. So this is the step that I'm kind of running here, which is essentially to find out the pod definitions, make sure that it's actually running engines here. So we'll need to do a grep because there's a lot of data here. It's kind of pain to kind of like look through it properly. So yeah. So there it is. So let's make it smaller. Let's go to the next slide. So with that, the initial configuration is kind of done. So now we have that Google Sheet sync resource on the cluster, and we have our component that is kind of syncing the state of our spreadsheet to the cluster. So our spreadsheet says that we have 4 engines under the LOL deployment that we need to kind of run. So how do we take this and then make it more complex of sorts? So let's view this, and then let me up the quality. 720, it should be okay. So hopefully there's no technical issues now. All right. So I will later be sharing the videos to this actual demo so that it's more clearer that way. So on this portion, what I'm trying to do is, okay, I think it hanged. Okay, give me a moment here. Okay, it's running. Okay, so what I'm trying to do here, essentially, let's say if I change the state in the Google spreadsheet. So how do we... Okay, hold on. Okay, so we are back. So what I'm trying to do here is, let's say right now we have like 4 replicas for our cluster. We just changed the spreadsheet to 2. Let me go back to that section. So over here, that's what happened here. I changed 4 to 2. So we kind of need to kind of wait it for a while to see that it's happening here. So as time goes by, because we are running this on a per minute schedule, so what will happen is on the minute, the third minute, you will see that 2 of the pods will start terminating, because on spreadsheet we says that we only want 2 of these engines pods running for this lol deployment object. So on the third minute, you'll see 2 terminating, and then we'll have what we kind of declare in our spreadsheet. Yeah. So let's take it a step further. And then let's say if you want to have like 2 additional deployments. I'm using engines here because I'm kind of lazy to kind of create new application deployment applications to demo this. So let's say we have a YA deployment and the AC2 deployment. And as you see just now, we have LOL will be 2 pods, YA will be 3 pods, and AC2 will be 5 pods. All of them will be running engines. So we'll just wait for the 4-minute mark, which is, because the component is running on per minute basis, and 8 more seconds, 5 more seconds, and then here comes the 4-minute mark, and then now you'll start to see things happening. So the controller now fetches the data from Google Spreadsheet. It realizes, hey, the state is now different. We kind of need to update the Kubernetes cluster accordingly. So yeah, that's kind of what we can do with this whole mechanism. Like, we have this component that can talk to the Kubernetes API and like alter the state according to what we kind of want or desire. And this component talks to Google Spreadsheet API to retrieve all that data that we kind of declare in the spreadsheet. So rather than just showing demo, right, I think it's best to also explain like what's actually happening behind the scenes. So how does it exactly work? So if you are following along, essentially the main bulk of the work that's happening is all under this reconcile step. So as you know, in Kubernetes, it's all about the reconciliation. Like essentially, you have a desired state that you need to reach, and you have the current state of the cluster. And the whole point of all the components within Kubernetes is to reconcile to the desired state. So it's a very apt name here. So let me take you through like what this whole reconcile function is all about. The beginning of the function is essentially quite simple. Essentially, we just like do kind of basic admin stuff, like getting what this Google Sheet resource is all about, and we kind of need to make sure that we kind of need to go extract out the Google Sheet ID, because we like if that changes, like we need to kind of change on the controller end. And the important bit here is essentially we kind of want it to run in a loop. So by default, if you see this function called control.result, right? If you don't return anything, if control.result is an empty object here, if you remove this request after, essentially that only gets called maybe every 12 hours or something. That's kind of like the default timings. Yeah, I'm not exactly sure whether it's really 12 hours because I haven't exactly tried it out. But we can't have that, because essentially we can have changes to our spreadsheet, and if it takes like 12 hours to reconcile, then what's the whole point of this integration? So if we add the request after, what this kind of tells Kubernetes is kind of like contact this component once more and tell it to reconcile after every 60 seconds in this case. So yeah, so the first part here is just a lot of like error handling of sorts. So in case it couldn't like extract the object from the Kubernetes API, we'll just log it out and then try again later. So it's just a lot of admin work. And then at this stage, let's say if we have a lot of items in our spreadsheet, we kind of want to say that we are still in the middle of it, so we want to update the status. But updating the status, there's a kind of a very specific instruction here. So apparently status updates is kind of treated as a separate resource on Kubernetes. By default, like if you are talking to it, and if you just say Google Sheet Sync resource, if you're trying to you're saying telling Kubernetes that you want to manipulate the Google Sheet Sync, by default is you're actually manipulating only the spec. You want to manipulate the status of it. In some cases, like example in the deployment, deployment has like some sort of like status field where you can say how many replicas are in this deployment. That thing is treated as a separate resource, so you kind of have to define it, and tell code key builder like, okay, I'm going to alter the status of Google Sheet Sync. I need you to create the RBAC files so that my component can talk to Kubernetes API. And also in the case of this component will also be talking and getting the deployment, because like we're going to alter a deployment on the Kubernetes cluster. We're going to create just now the example, the LOL deployment, the YA deployment, the AC2 deployment. So we kind of need permissions to go and kind of alter that as well. So we kind of need to add that. We need to kind of add what APIs that we need to we are going to interact with. So we need to interact with the get API of the deployment object. So we need to kind of list all this out. So if you want to find out more details about why this status is treated as a separate resource, etc., there's a link down there, so you can take a look. So just now I was showing you about the RBAC for the Google Sheet Sync resource, right? So that will kind of initially generate only the top bit, but then let's say you want to alter and change the status. This bottom bit is essentially the RBAC component to alter the status. So this is kind of a screenshot of that same reconcile function, but the second portion of that function. So there's this step. Naturally, before you get started with all altering your deployments on Kubernetes cluster and everything, you kind of need to get the data from Google Spreadsheet. So essentially, this is just an API call to contact Google Spreadsheet API. We provided the spreadsheet ID. We provided which cells that we are going to refer to. So yeah, this is kind of standard stuff. Like if you interact with APIs all day, this is kind of the bread and butter, the usual things that you need to do. So essentially, this is get the data from Google Spreadsheet API, and if it fails, try again, maybe 60 seconds later. Maybe at that point of time, Google Spreadsheet has an issue. Google Spreadsheet API has an issue, so try again later. Yeah. I just want to point out about this thing where I wrap this whole functionality around this whole thing where there's this last API call, etc. I will refer to that sometime later on in these slides. So the next bit after contacting the spreadsheet API is once we have the data, the next part is actually to create all the required deployments. So deployments on the cluster. So this part is the lengthiest bit, because for Google's for the cluster, right, you need to define a whole bunch of stuff. So in this case, you kind of have to the best way to kind of fill up all this data to pass before passing it to the Kubernetes API is, imagine you trying to write a deployment file. Imagine you trying to write a deployment file, and then you need to put in you need to have all that data in place before your deployment even works. So imagine that, and then you just need to apply that same logic of sorts to your code base here. So some of the things that you kind of want to fill up naturally would be your resources. You don't want your one pod to take one CPU, because that will kind of quickly run out of space on your cluster. So over here in this code base, what I put here is a fixed value, 100 millicores and 100 megabytes for memory as the initial starting point for the pod. And kind of like just an opinion here, but like it's good to kind of set labels as well. So like by default, like there's no labels set on the deployment or on the pods being deployed. But if you set managed by Google Spreadsheet Sync, so in the future, if someone else comes to the cluster and is trying to get like what pods are being managed by this spreadsheet sync controller, etc., it makes it easier to kind of do that, and then you can add that filter to filter out only for those set pods. Last sync is there to kind of like help you debug of sorts, I guess. I mean, this thing is not meant to go into production, but yeah, those are the additional metadata that should prove quite useful. And then, of course, the last bit is essentially just to update the status to say, hey, reconciliation is complete. And then if there's any error, retry again 60 seconds later. So one common thing that kind of hit me while I was building this is this thing called a reconciliation loop. I mean, I call it reconciliation loop. I'm not sure whether it's a thing out there in Google, when you search on Google. So by default, what happens is if you when you are updating a status, Kubernetes counts that as an update to the resource. So because there's an update to a resource, Kubernetes says, hey, there's an update to resource. I need you to reconcile this. So by default, if you look back here, right, I have a update status here to say reconcile complete. I have another update status somewhere at the beginning, like over here, like there's a sync status update to reconcile the thing. And I think there's one more in the code to say there's an error or something. So those three are counted as 3 status updates. So imagine this, like let's say first time you deploy the resource, and then you receive this status update. It counts that as a update, and then it requires you to reconcile. So now Kubernetes receives 3 additional reconcile requests to the component, and then it goes on over and over again. So it quickly builds up. So now that causes other issues in the code base. So just now, if you remember this code base, right? Essentially, what happened from me not doing things right is the Google Spreadsheet API started receiving the 429 error. 429 means like too many calls to Spreadsheet API. Yeah, so it's kind of like a loop that goes worse very, very quickly. It's an exponential reconciliation loop error or something. Like once it receives the status update, once it receives the request to reconcile, it receives another 3 more requests to reconcile. And yeah, it gets exponentially worse very, very quickly. So to kind of prevent this problem and to say that, updating status does not mean status update. There's this one line that you need to add. With event filter predicate generation change predicate, essentially just saying if my resource is of a specific generation, I think the generation is based on you specifying the spec or something. If it's not changed, don't count that as a status update. So that kind of stop it like kind of immediately. So just this one line can prevent that one entire whole problem. So yeah, so if for those who are trying to build all these operators or thing, don't forget to add this line if you are doing status update. Because if you're doing status updates and you don't add this line, essentially your component will be updating forever. Yeah. So so all this code, I don't exactly. It's just a general overall. I can't exactly deep dive because firstly, it's Golang code. Not everyone here codes in Golang, and then it's kind of hard to kind of go deep into all this Golang stuff. Essentially, the best way to kind of experience it essentially is to clone it and deep dive into the code. or maybe just use Quick Builder and build your own. That will be I say the best way to kind of understand this whole thing. But yeah, going back to that, let's say you take a step back and like trying to understand, like, is this solution even a good idea to go along or to follow through? There are many issues that this whole the code that I built, that I wrote, that doesn't resolve it. So one thing is, let's say in your custom resource you define A1 to like cell range A1 to C as your cell range to input your data. If some guy decides to insert a new column at the front, essentially this integration is immediately broken. That's one. Yeah, so it's kind of hard to kind of make sure that no one edits the spreadsheet, and make it broken like pretty easily. Like it's like, because there's more people that can access it, it's more accessible to more people. It makes it really hard to kind of prevent people from altering the tables and moving data around. Yeah, it just makes data validation really a really hard problem. That's one. Another one is, on spreadsheet, there's like the principle is kind of similar to GitOps and everything. Like, you have this external resource, you just define all your stuff in this external resource, like on your Git repository. But on a spreadsheet, there's no way to kind of say to version the data on that spreadsheet. So yeah, that is kind of another gripe that I have. But that's the thing, like if people find that this is the okay solution, like they can go for it. I'm not going to say anything much about it. So for those who are like kind of interested to find out more and everything, firstly, there's this repository at the top. That link there, you can kind of look at it and kind of look at the code base and see how it works. Deploy if you want. The make commands should be pretty simple, and you can kind of adjust it accordingly. That's one. Another one is this, or the frameworks that I was mentioning. Like, there are two kind of popular frameworks to help build these Kubernetes operators. One is the Kube Builder operator. Not Kube Builder operator. It's the Kube Builder framework, and another one is the Operator SDK. So these two are different frameworks from two different organizations, and they can kind of set up the initial boilerplate code, because there's really a lot of boilerplate code that you kind of need to write just to get started with this. Like, you need to do authorization and authentication on the cluster, etc. So these frameworks kind of like help to do the initial boilerplate code, so that the first thing, like once you have that whole thing established, you can immediately build the container and immediately kind of deploy it to a cluster, even though you have no functionality yet. So I guess like being able to deploy the cluster is like a good first step, because like if you don't have that, like it's kind of hard to eventually kind of do all that code to kind of get to the cluster. And because this code base kind of requires reference to spreadsheet, so naturally the Google Spreadsheet API, and I put the link here for those who are unfamiliar with it. So to kind of prove my point that this idea of mine is not is kind of crazy, but there are other people that are crazy out there. So one, there's this YouTube video shown on CNCF about this person deploying stuff via this. They coined this term called shitops or something. Hopefully it's not a thing. Hopefully it won't be a thing in the future. But yeah. So the person, like similar to what I showed in the demonstration today, the person like put all her stuff, all the data in spreadsheet, and then eventually it'll get synced up to the cluster. The good part of that, or this YouTube video that I shared the link here, is at least the first portion, at least is a thing that she'll be talking about, a thing that makes sense, which is the GitOps portion, and then she relates it to this shitops thing that I was talking about since just now. And the funny part about this YouTube video is like at the end, people started asking a lot of questions about shitops. And here I am. I will be hoping that this shitops won't be a big thing in the future. And in case like you are kind of questioning also, there are other people that also built this shitops thing. So if you want, you can also look at this repository as well. So yeah, that's kind of it on my end. Let me stop sharing. Okay.
Okay, can you hear me?
Yes, I can hear you.
So thanks for the sharing. That was
Oh.
very interesting stream of ideas. I think especially for those in the audience, if you have maybe for students, I think especially if you want to explore something during holidays, this is a good way to learn certain tools in GCP, along with in a very funny way Google Drive. Okay, so let's take a few questions. So I have some questions. It's mainly from me. So do you think it's possible to replace with something proper? Like I think chat ops is something that is quite prevalent. And I've seen some people using chat ops to do deployments. So given what we have built so far, like by just changing the inputs to come from, let's say, a Slack channel, do you think that's very much something that's very doable?
Okay, from what I understand, Slack doesn't have like a data source, like a more persistent data source. If Slack has it, that would be nice. But yeah, you need that persistent data source that you can kind of easily fetch the data off from. If you can somehow format your chat to like get all that data in, that I guess that would be great. But I guess that would be quite difficult to kind of tease that data out from text messages. I mean, it's possible. It's just that you want to do it because like let's say if you put all your data in text form, right, and then like maybe you put in that data, you put it that text maybe at 12 p.m. and then you realize you actually made a mistake. You put that text again at 1 p.m. Like how do you differentiate the two and which one to reconcile to? Like do you reconcile to the latest one no matter what? But what if the latest one also has a typo? That's like, okay, now you have a problem. So you have additional issues that you need to kind of solve. But yeah, I'm not saying that it's impossible. It's just that it's really, really hard. It's questionable. It's really, really to the questionable end. And in terms of, but let's say if you take another step back, so rather than like looking at deployment, but maybe you look at just chat out itself. Like if you want to just, if you have a persistent store, like maybe you store all that data in a database and then you use chat ops to alter that database, maybe that kind of makes sense. But then that's not exactly interactive with Kubernetes API. Yeah, there's a slightly different use case here.
So in the case of shit ops, you have both interface and data store. But
yes,
for chat ops, yeah, it's only interface. You need to find some way to supplement the data store.
Yes, you need some sort of the data store portion. Or if you are passing it off the chat, I mean, I'm not saying it's impossible. It's just if you can put the data in the chat itself, and like you need to kind of pass it and like make sense of the chat to find out the data that you need.
I think it could be possible. Okay, so let's see. Another question. So again, this is something more curious for me because I realized I haven't seen your ID before, and I think I was looking at the left side and I saw there was a few very interesting icons over there. It looks like a GDG, that icon, and I don't know if that's yeah.
I think it's the like what you mentioned. I think it's a Google Cloud integration. Google, yeah, the cloud run, the cloud code integration. I think, if I'm not wrong, the one that allows you to like view like what contains in the cluster, etc. Like yeah, and I think can do cloud run as well. But I like to be honest, I barely use it. I installed it. I tried it one time. I thought like, okay, this experience is nice, but then what if someone else? Because I was like testing different tooling, and I need to find some sort of tooling for on my company. What is the easiest way to kind of bootstrap code, etc. I'm kind of finding some sort of tooling behind it. this looks promising, but then in the place where a person doesn't use Cloud Code, Visual Studio Code, how I until now I still have no answer or solution to that. But yeah, it's like what you mentioned. It is one of those the Google Cloud Code integration with Visual Studio Code.
Awesome. I'm gonna check that out. Okay, last question. Any ideas for the next implementation of this? You're gonna do it with like some crazy AR VR.
Actually, like, I mean, okay, I never tried AR VR. I did thought of something like a bit wild, where what if you could, like, declare this data and put it into Google Drive, etc. Like, you have this file system, right? And then you create a folder that represents on the root level, and that represents a cluster. And you can create folders to represent namespaces, and within that folder you have like deployment folder, and within the deployment you have like maybe a text file, and then you fetch from the text file. Okay, but then again, this, like, don't do this. At the end of the day, this is like, these projects are for fun. These projects are kind of building stone to kind of build to kind of help you learn the Kubernetes API, etc. But I'm not sure about AR VR though. Like, AR VR are interfaces. We'll still need some sort of data source, but yeah.
So everyone, you heard it here. If there's a drive ops coming one day, you know that it's this guy is gonna be part of that.
But yeah, please don't use it.
That'll be really interesting though. All right, so I think that's the last question that we have for today. Anyway, yeah, it was really great to learn from a very refreshing and different perspective of how you can do deployments with Sheets. I think it has been out for some time, but it's always nice to see it being shown right in our faces.
Yeah.
Anyway, thanks for the very interesting sharing. Yep, so I think let's move on to our next speaker. So I'm going to share my slides again. In one moment. All right, awesome. So last but not least, we have one last speaker today who will be sharing with you his experiences in using BigQuery. And today we're going to explore that in terms of both BigQuery and TensorFlow. So over here we have Akilesh. I'm going to bring Akilesh in. Give me one moment. Hey, Akilesh.
Hi, how are you?
I'm doing good. You?
Good. Thank you very much.
Awesome. So the floor is yours. Take it away.
Sure. Yeah, thank you. So today's topic will mostly be about we will not be digging deep into TensorFlow or how to build TensorFlow models, but we will be looking at how to import a TensorFlow model in BQ and then use that model to make some predictions. So it's as simple as that. We're just going to look at the other options, the available options for doing that. So I'm going to go ahead and share my screen here. And I don't have a slide today because I'll be running through a Colab notebook where the overview is simple. Sorry, can you see my screen?
Yes, you can see it's. Yeah.
So this is sort of the table of contents. And this is what we will be doing today. We will be creating a TensorFlow model, and we will be moving that model to GCS so that we can import the model into BigQuery. And we'll create some test train validation data sets and then move them to GCS just for testing purposes and validation purposes, and also like evaluation. And we'll create BigQuery tables for those test and validation data sets. And yeah, this is some authentication of Colab. I've tried to squeeze all my code into Colab so that I don't have to keep switching tabs. But yeah, you can always execute the queries found here in BigQuery directly. So that should work just as fine. And then we will be creating a TensorFlow model, and using the validation, using the test data set, we will be evaluating the model in BigQuery. And then finally, we will create a really small data set with reviews. So the TensorFlow model that we're going to build is of movie reviews. So given about 25,000 reviews, we're going to build what is called a RNN model. I'll be discussing a little bit about what an RNN model is and why we're using that. And then, so using that model, we're going to pass some reviews and see if the model is able to predict it right. So that's kind of the overview of today's talk. So yeah, let's just dive in. So first up, we'll create a TensorFlow model. So this TensorFlow model, so all the code for this TensorFlow model is available in this GitHub repository. I just figured this out today. So apparently in Colab, you can save a copy in GitHub, and before you do that, it'd be nice if you just clear all the output so that your GitHub repo, like, you don't have to scroll a lot. Otherwise, anything, if you're running for, if you know TensorFlow, and if you're running for like a few hundred epochs, the output will just, the output will also be shown on GitHub, which is pretty, you have to keep scrolling a lot. So I just figured that out today. So I directly pushed my Colab notebook into GitHub, which is pretty cool. And just have to click on open in Colab, and it opens Colab, and you can just go through the entire notebook all by yourself if you want to try at your end. So it's pretty simple. So we're going to use what is called a TensorFlow. So the idea is you have a bunch of movie reviews. These are all standard data sets that's available in TensorFlow data sets. What we are taking are IMDb reviews, and we're saying about 60% of them is training data, and the remaining is test data. So the remaining is the remaining 40% is validation data, and the remaining is test data. And what the model that we're going to use is something called an RNN model. So the idea behind RNN on a very, very superficial level is like, you take, suppose movie reviews look like this, right? Movie reviews are not always, I love this movie, I don't like this movie, or it's not like one word or two words, like a couple of words. It's mostly like sentences. So RNNs they're called recurrent neural networks. What they actually do is they sort of memorize the sequence, or if it says bad movie. So let's say, for example, if you have a sentence that says the movie, the CGI was quite bad, but the movie was good overall. So it kind of is a positive review. Maybe the CGI is not bad, but on the overall picture, the movie was good. But if you just, probably if you have a neural network, it would say there is the CGI was bad, and it would think that it's a negative review. So RNNs sort of like handle that problem of sequence, where a word that appears later on affects the word that's coming early on. So how humans perceive as a review. So that's like a very, very superficial overview of what RNNs are. So we are going to use the IMDb review. So this has like 25,000. The training data set has, I think it has 25,000 reviews. So the test data set has 25,000 reviews. That's really not the subject of discussion here. So we're not actually, so we're just taking what we call an embedding. I'm not going to get deep into this. So we are initializing the hub layer, and we are building what we call the RNN layer. So we have a hub layer, and then we have a dense layer, which is where all the weights are calculated. And then we have a final dense layer for making a prediction if it is 0 or 1. And so this is sort of the basics. We're using what we call binary cross entropy, because this is the classification problem. It is a binary classification problem, which means we are predicting if the value is 0 or 1. 0 stands for it's a negative review, and 1 stands for it's a positive review. So, and the metrics is accuracy. The optimizer is something that we call Adam optimizer. So while fitting the model, we shuffle the data set, and then we split them into batches of 5 and 2. And we just run for 20 epochs. This is just very, I'm not running it for a lot of epochs. So let's just start running the code one by one. I'm just going to, where did I see restart runtime, so that I can show you how this notebook works as well. So getting the train data, validation, and the test data, I'm initializing my hub layer, and I'm building the sequential model. So if you want to play with it, if you don't know TensorFlow at all, if you know BigQuery, but just want to know, try all of these movie reviews, this model by yourself, you can play around with the number of epochs, see if the accuracy is higher or lower. Probably, yeah, that would be a nice thing to try. So this is where we're fitting the model. So it will run for 20 epochs. So this will take about, it takes 3 seconds for one epoch, so about 60 seconds to run everything. So we'll just wait for that until that is complete. And yeah, we'll just wait. So as you can see here, this, if you're not familiar with TensorFlow, this is what's in after each epoch, which is one run of the entire data set. The loss was 69%, the accuracy was 59%. The validation loss, this is on the validation data. So the validation loss was 62%, the validation accuracy was 63%, and it's slowly increasing. The loss is decreasing as we expected, as it should be, not expected. And the accuracy is increasing, and the validation accuracy, the validation loss is decreasing, and the validation accuracy is also increasing. So that's a good thing. We've just run for 20 epochs. You can run for more epochs to have a much better accuracy, and much better accuracy and much better validation accuracy. And then we use the test data. This is so we're taking the training data to fit the model, and we're using the validation data to see if the model that we're fitting after each epoch is performing well or not. And now what we're doing is we're taking a completely new data set that the model has not seen at all. And then we are evaluating the model with that test data. And then we get the accuracy. The final accuracy that we get is 85.5%, which is kind of okay. So what we're going to do here is we are saving this model. So when you save this model, the model will be, so in Colab, the model I think will be saved under temp. Oh, it's saved here. Sorry. How do we go back? Oh. I think it would be under temp or content. Yeah, it's under content model v1. When you just save it as, when you just do model.save, it will have a PB file, and then the required assets and variables that come associated with the model. So mostly when you're building with TensorFlow, what you have is sort of this folder, folder that I showed you, which is a model v1 folder. So what we are going to do is import this model into BigQuery. So to do that, I've experimented with, I've kind of installed the Cloud SDK in Colab. I just wanted to try this out. In the later cells, I've used just the Python API for G-Cloud, and then I've used it to run queries. But I just wanted to see if this worked. This worked, but then this installation sort of took time. And if you run G-Cloud init, it's going to ask you a bunch of things. If you want to reinitialize the same configuration, yes. That's my personal Gmail. I'm going to give that. I'm going to give one. So I'm going to use this project for now. For now, I don't want the full computation. But this was fast. This actually took some time for me. Maybe because I know it already exists since I just ran these cells before the session. So this took some time, about like 3 to 4 minutes for the entire SDK to be installed. So once that is done, what I'm doing here is I have a bucket name called with my name and TensorFlow models. And then I'm simply using the gsutil command to copy my existing model into my bucket. So I run this and it's copied all the required files in the model we want. So we need all of these files before we can import it into BigQuery. So here, what we are doing, this code is actually, I got this code from one of the blog posts that explained in detail how to run all of these, how to import a model into BigQuery and make predictions. I've added the reference at the bottom of the Colab notebook, so you can look at that blog post for more reference. This is quite basic. What it is doing is it's taking a TensorFlow dataset and then it's converting that into a CSV. Because with BigQuery, you cannot directly import. I'm not sure if we can directly import a TensorFlow dataset within BigQuery. So one of the ways is to convert this to a CSV and then load that into a table. So create a new table and then load that CSV into a table for us to play around. So we just take the again, we take TensorFlow dataset.load and then we split that into train, validation, and test data, and then we split the train, test, and validation data into CSV. So this very small function is just doing that for us. So I have train, validation, and test. So if you see here, it is simply going to write the file name as train.csv, validation, or file name.csv basically, but so it's going to write it as train.csv, validation.csv, and test.csv. Once that is done, I am again going to use so this time I have another bucket, GCS, in GCS called datasets Akilesh, and then I am going to simply copy my train, validation, and test sets over. Run this command. And boom, it's complete almost. So yeah, so this is done. So the next step is to create two tables. I just have this IMDb data set and then create two tables, samples and test, and then load the CSV into the samples and test tables. So you can do that in the BigQuery console, but since I didn't want to move away from Colab, so that anybody trying this out can just needs to run each cell, I kind of created that. So you just make sure to change your project ID. It's whatever project ID you're using. And while you're authentic, I have already authenticated. So, but if you have not authenticated, when you run this cell, you will have a prompt which says it's self-explanatory, and then it would just say, click on this link and then copy a code, and then paste it back so that you're authenticated. So once you're authenticated with your GCP project, you just give the project ID, and then here it's just a very, very simple Python code to do this. You initialize a client with the project and the given with the project, and then you specify the dataset ID. In my case, the dataset ID is IMDb, and the table name that I want is test, and the table ID is just a string of project ID dot dataset ID dot the table name. So then we use the load job config function to create the table for us and load the data for us. So here is where we describe the schema. So like I mentioned before, my table is so if we just take a look at this file, I hope I can run this here. Let's see. If you go ahead, what I'm trying to load is that CSV test.csv. This has only two columns, text and label. So in my schema, text is a string, and the integer is the label is an integer. So the label is either 0 or 1, so it's an integer. So here I define my schema as text, and then that's a string, and label, that's an integer. And since the first row is the columns, I'm skipping the first row. And write disposition is going to tell me if I have to override the table or append or fail if there is existing table. So in my case, since I'm just playing around with this, I just want to override the existing table if it exists. And the source format is CSV. So this is a CSV format. The default is CSV, but I'm still mentioning that so that it's clear for me. So then you define where you're getting the data from. You're getting it from Akilesh, and file name is test.csv. The URI is the file name, the GS bucket name of the file name, and it's a simple load command. Client.load table from URI. You provide the URI, and then you provide which table you're going to load, and then you provide the job config. So if you run this, so it's loaded 25,000 rows. Our test data is 25. It consists of 25,000 rows. I didn't actually validate this, so let's just validate that now. Yeah, it has 25,001 rows. The first row is the header, so it has 25,000 rows. Just out of curiosity, I just want to see how big my train data set is. Minus L. Actually, okay. So after you've created the table and loaded the data in the table, then we create the model. I mean, we already have a TensorFlow model. We are actually loading the model. So this should be creating the model. So it's basically like loading the model. So loading the TensorFlow model into BigQuery. So again, you can run this command in BigQuery like that, where you replace the model name with whatever my model name, and this should work. But yeah, I don't want to move away from Colab for the moment. So here I'm initializing my model name as the movie classification model. If you see here, I already have the model name movie classification model. I'm going to go there and delete that. And this is a very simple Python the API where we're just creating, we're executing this query. And if you run that, so just a bit of explanation. So the model, of this code, what is happening here is create or replace an existing model. If there is an existing model, replace the model, and model is defining the model, and IMDb is the dataset ID, and model name is whatever model name you want, and the options in the options parameters for the options, the model type is TensorFlow, and model path is the model path where you actually moved your model to. So if you look back up a bit, so here we saved the model to V1, and then we moved it to TensorFlow models. Yeah, Akilesh TensorFlow model. So it is GCS. Bucket name is Akilesh TensorFlow models, and the model name is model V1. Model underscore V1. So if you look at the code here, the model path is GCS Akilesh TensorFlow models, and the model, it's model underscore V1, and every file that is included there. So you have the PB file, you have the assets and the variables. So once you execute this, it kind of loads the model into BigQuery. And if you look here and refresh this, so go into my project ID, IMDb. Yeah, the model is created for us. So it was 158 my time, it's 159, so it was just created. So if you look at the schema of the model, that's something interesting. So when TensorFlow, when BigQuery loads a TensorFlow model, it so the label is dense. That's the schema for the labels, and for the features, it is Keras layer input. So we'll be discussing a little bit about this as we move along. So once the model is created, you want to evaluate the model. So model evaluation is again executing another query, which seems a bit scary at first. It's sort of seems like a lot is happening here, but I'll just try to explain what's happening here. So at first, what is happening is I've also added a little bit of, try to add a little bit of explanation to this. Hope it helps. What we are doing, since the model, if you look at the schema, it is expecting a column named Keras layer input. So what we are doing here is we are taking the test data. If you look at the test data consists of two fields, text and label. And if you do a preview of that, it says this is a scary movie, blah, blah, blah. And it's the review is 0. So it's supposed to be a negative review. So we, using the test data, we have the text as, we convert, change the column name of text as Keras input layer. And then we have the label as such, because what we're doing here is evaluating the model. So when you run this piece of code, I've added a break statement here because I don't want to show you all the rows of it. So it will do, so a little bit of explanation of this query as well. So it's going to predict, ml.predict is predict using this model, the model that we just created. And then the input to that model is the Keras input layer, layer input, and the label. And once you have that, you're going to have something like this. So this is the prediction that the model has given to us. And yeah, so dense zero, yeah, this is the actual prediction. The actual value. So it's 0, and you really cannot make sense of this value at the moment. It's just giving you a probability that's -3. So what you do next is you take this value and then pass it to what we call a sigmoid function. So this is a sigmoid function like written in SQL. So what a sigmoid function does is you give it any value, it's going to fit those value between 0 and 1. I can try to explain that a bit, but then for like on a superficial level, that's more than enough to just play around with this model. So if you pass in -3 point whatever to a sigmoid function, I hope there is something that converts this. I've tried something earlier. Execute. So yeah, it kind of fits the, I think this is correct, but it fits the value between 0 and 1. So if you give 100,000, it will still give you a value between 0 and 1. And if you give that's giving you 1. Point so yeah, kind of get the point there. So it gives a value between 0 and 1, and then what you do in the next step is you take the value between 0 and whatever you're getting. So when you run this, your -3 point whatever 3.05 is now yeah, it's already predicted that as an integer, so it rounds it off to the nearest value. So I really show you that right now. Let's try adding a break statement here and see if that works. So Select asterisks from predictions. It really does not have the So how a sigmoid function, the formula for a sigmoid function is just take a look at that. It is 1 divided by 1 plus e to the power of minus x, where x is the value that you're passing in. So a sigmoid function will have values between 0 and 1. So that's kind of the curve for a sigmoid function. Oops, sorry. So it's actually since the value that we got was like less than or equal to 0.5. So that's what is it. It executes the sigmoid function, and it measures the value. And if it is greater than 0.5, then it is rounded off to the nearest integer, which is 1. And if it is less than 0.5, it is or equal to 0.5, it is rounded off to 0. So that's what's happening here. So and yeah, that's pretty much what's happening within this SQL query. And here, what we are doing, the extra step is we are actually evaluating this model in BigQuery. So we're taking the predicted labels and we're just finding the number of the accuracy depending on the number of labels that were correct, and that divided by the number of labels which were the total number of labels. So you have an accuracy of 86.46. So that's a pretty decent accuracy to play with. Okay. The final step is, so we have a model, we've evaluated the model, and we see that we have an accuracy of 86.4, which is pretty good. So now let's just play with some data that we have created. So I have some data here. So this was an awful movie, excellent movie, not too bad. These are all very small sentences. Good background score, but terrible plot. This is something that I just wrote. And this is actually from the data set. I just wanted to see how the model was performing on the data that it has already seen. And yeah, these are just a few comments that I just got from the internet, and I just wanted to see if it made sense. So again, just creating, it's a very simple function to convert, create a data frame, and then convert that to a CSV, and copy the CSV into GCS. And again, I created a table called samples, and I'm loading the CSV into samples, again using right truncate to override any existing data there. This is the same function that we saw earlier. And now again, I am simply just doing a prediction. And let's see if this prediction works well. So this was interesting. Oh, this is interesting. I actually got 0 while I was playing around with this. So yeah, the model is able to say this was an awful movie is a negative review. Excellent movie is a positive review. Not too bad is actually a positive review, but it has given it as a negative review. Good background score, a terrible plot. Just actually, it's able to understand, even though there is good background score, but since there is also a terrible plot, it's actually a negative review, and the model has actually predicted that right. I just wanted to try. So this was a review for the movie Shawshank Redemption, which is one of my favorite movies, and yeah. I think this is, no, oh, I think I missed a comma somewhere. That is why, yeah. These are all separate reviews. So for like a live demo, let's try a very negative review. So sorry about that. I missed on the part where I was showing you, I don't know, probably this is, yeah, so this is a positive review, it says, but actually starts negatively. That's interesting. So yeah, this is a very negative review. So we are going to add this to the list of reviews that we have. And we are just going to take a positive review, some positive review, IMDb review, shooting in the dark. It's a movie name. Nothing here. Just gonna go with oops. Sorry. Okay. Really don't know how to get a review from IMDb. Playing with the IMDb dataset, that's sort of pathetic. Let's go with the Dark Knight. Where did you find the reviews here? This is a really long review. We don't know if this is a good review or a bad review. Just gonna take this and then we are going to add this as part of our reviews. See if, and then later on see if this is a negative or a positive review. So again, I kind of created these Python integration with Colab so that I can do this easily. Getting data into GCS and then into BigQuery. Let's see. Yeah, so yeah, I think this was one of the reviews from Shawshank Redemption. Let's see what the review was. Yeah. So it's a positive review. The Dark Knight was a positive review, and this was supposed to be a negative review, and it's predicted that it's a negative review, so that's pretty good. So this is what RNN is very good at. So even though you have such a long sentence and there's so many words, some of these words are like interconnected. Like a word at the beginning of a sentence will only make sense depending on the word, will give an entirely different meaning depending on the word at the end of a sentence. So these are something that RNN is very, very good at. So I would say that our model is like performing decently given the data set. So we can just take the script or a bunch of reviews and see if a particular movie is having a good or bad review. Yeah, so that is about importing a TensorFlow model in BigQuery and then making predictions with it. So if you have a lot of data sets, you just have to like make sure that your data set fits the input criteria for prediction with BigQuery, and I think that should be it. Nothing fancy here. It was pretty straightforward and simple to execute, and I think that's a pretty powerful tool, especially if you're using BigQuery a lot and you don't want to like have an additional a setup for using your TensorFlow models and then have with the API calling the TensorFlow model and then returning the value and displaying that. But if you just want to play around with BigQuery, then I think, or if it is something like you have a BigQuery ML model and then you want to compare that against a TensorFlow model, I think that this is a nice way to test that out. So yeah, that's pretty much it. I'll stop sharing my screen here and we will see if there are any comments or questions.
Yes, there's a few questions. Okay, maybe I can pull them out starting from the top. So I had a question because I've not used Colab before, and I understand that like it looks like you're using like sort of a VM, right? There's a RAM and CPU stats on the side. Is it?
Colab is free.
It's free?
Yeah, Colab is free. You just need your Gmail account and then uh, create new notebook. All your notebooks are stored in your Google Drive. So Colab is free. Colab is a very famous starter kit for anybody who's learning machine learning. So you can change your runtime to the default is none, but you can change to GPU. I've never played with the TPU, but the GPU is like quite powerful. Like if you're running the 20 epoch with a GPU, I'm telling you this time will be like super reduced. Like it will be really really low. So yeah, Colab is free, and they have nice code snippets. For example, if you want to integrate with open mounting Google Drive, you add that. I don't know where it adds. Should I select the cell or something before you do that? Yeah, it will add it below the cell that you selected. So very handy. You don't have to, remember a lot of code stuff. It's pretty interesting and very very easy to work with.
Nice. Definitely check that out. Okay, so I'm gonna go with another question. So I think Hairizuan was also mentioning in a separate comment about ML ops, and I think his question over here is mainly referring to ML ops. In terms of automation, is there a way that you can use Colab maybe be able to run that? So let's say that file is saved in Drive. Is there a way to reference it and maybe run it repeatedly?
On a daily basis, I am not sure of that, to be honest. I've not tried that out, but that's an interesting. That's something interesting that we could try out. Probably for next time.
Okay, then maybe let's look at this BigQuery question. So you're saying that BigQuery is batch-based, can we request and predict results on demand?
I think, with the prediction, I think there was a quota limit, if I'm not wrong. But I don't remember exactly right now. I'll get back to you on this one. With the cost for, if you've used, I'm not sure of the TensorFlow thing. So while you run this command, let's say query history, and creating a model, if you open it in the query editor, it is actually 0 megabytes. So this is the cost factor in BigQuery. So and if you go to query history and if you are running the predictions, our data set is really, really small. So it is like 4.8 megabytes. So that's the amount of, that's the cost associated with running this query. Depending on your, I'm not sure if I've used batch in BigQuery before. I can try that out and then I'll let you know if batching kind of works or how to use it if it exists.
Or maybe would it be possible? Like I guess maybe a pricing calculator might have that information as well, just to give the estimate.
A pricing calculator. Not sure about that right now because it's been a while since I played around with BQ itself. I've been experimenting with stuff like new stuff in BQ. So there must be a quota limit for this, I think. I can get back to you on this one. Sure.
Okay, I think let's go to another question. So I think this is a bit slightly related to what you just mentioned in regards to using Colab and
generated on CPU or GPU. I think for now CPU, but it can also be generated on a GPU or a TPU. I just showed you how in Colab. So in Colab, let me just share my screen again. So in Colab, if you just go to runtime and change runtime, you have GPU or TPU here. So that's how you change your GPU or TPU. Just for fun, let's just say, so this took 3 seconds, right? I think it took 6 milliseconds for each step and it took 3 seconds. I'm just going to change the runtime to GPU And once I change that to a GPU, the runtime is actually reset. So I will have to run everything again. This won't take a long time. One thing to be careful with Colab is if you create, so all these files, train.csv, test.csv that we saw earlier, they will all be gone once it's a VM. So once your session is over with Colab, when you restart your runtime, all that data is lost. So when the runtime was restarted, now it's actually downloading all the data for me. My previous runtime is gone. So that is when it's best if you mount Google Drive with Colab and you have all your data set in Google Drive, and then so that you don't lose your model checkpoints or your model output. That's one of the best practices for using Colab. Run this before and run this after. File the model, fit the model. 1 second less, but yeah, from 82 milliseconds to 67 milliseconds. Slightly faster, but when you start using what we call convolutional neural networks, the CPU versus GPU makes a huge difference because those are like you have multiple convolutions, you have multiple pooling layers and stuff. So that's when a GPU is very helpful. I've not tried the TPU. I think this TPU setup requires it's slightly complicated, I think. I'm not tried it out. Maybe it's easy. Maybe they made it easy now. Oops, sorry.
So, okay, I think we have one last question. Hairizuan.
Notice that you write the PQL skills,
So he's asking syntax checking for when you're
with
writing.
Colab, no. The way that I used to write BQ queries, and I used to write it in BQ. And in BQ, if you make a mistake, then BQ will tell you that that's a mistake. And if you have, you can just format the query. And I don't know why BQ is not telling me that's a mistake. That's not a mistake. If I added it after the select statement. Yeah, that's not a mistake. So unexpected at 3.9, so 1 to 3 at position 9. That's quite detailed, but then yeah, you can do that. Or I've tried it with VS Code and Atom, and oh sorry, I am not sharing my screen.
Yeah.
Sorry. So if you in BQ in the console, if you make a mistake, if you're like typing it all wrong, then BQ will give you a warning saying like unexpected comma at the end of the line. So I write my queries here, and then I copy these queries and then put them in Colab. But I've used kind of like syntax check and also autocomplete with, I think, Atom or VS Code. I forget which one. They have these plugins. BigQuery, which will give you sort of like not an Atom, then probably VS Code. Yeah, VS Code BigQuery thing. That was pretty interesting when I was playing around with that. So we have like all the code is written in Python. You use the G Cloud library for that, and then it's just I'm not sure if this is the exact one. I can like find that out and then I'll pass it along. I'm not sure exactly which one it is. So that was pretty interesting. It just it has standard and legacy SQL. I think this is the one. I wish they had like a GIF or something that shows how the autocomplete works. That was pretty cool though, and it worked perfectly well.
So yeah, either using the BigQuery console or you have an editor that supports.
Yeah, but the BigQuery console is something that I prefer because If you have your own way of writing SQL queries, formatting it in a particular way, then that's fine. But then if you don't have a particular way of formatting, you can use the BigQuery format option that will format it neatly for you. But yeah, it's preference, I guess.
Thanks for the tips. Yeah.
Yeah.
Right. So I think that's the remaining questions. As in, that's the last question we have for today. So yeah, I think that was a really awesome sharing. Thanks for sharing with us today.
Thank you for inviting. So
Right. Okay, so let's bring up. So we're going to our closing now. Let me bring up some minor announcements and stuff. Give me one moment. Okay, so yep, that's what we have today in terms of sharing. I hope you guys have enjoyed the different topics. Definitely all three speakers with different types of topics, different discussion points. I hope you guys have learned a lot from them. So just to cover a bit of, DevFest is usually like sort of the one big event at the end of the year, and usually after DevFest, there's like nothing else left for like maybe the November to December period. So if you're looking for something to do, in this next few months, in fact, we have a few recommendations for you. There's still DevFest, one more festivities going on. One more week left next week, so make sure you tune in for that, which is the first week of November. We'll show this link again later on. And yeah, for Google Cloud, some event rosters, you can actually go to, let's wait for that to go away. You can go to their events page. You can see over here, Cloud on Air with google.com. Search for the upcoming events. So this will show you all the upcoming events that are happening so far. Public Sector Summit, I think that's something that we actually covered about before. This will happen in early December. I think there's some also interesting ones, the certification preparation, for example, for ML, as well as the later one in December for Google Cloud certification. I think that one should be a more generic one. So if you're interested, this is the period, November, December, where there will be lesser Google-based events, but more, community-based events, but more of Google-based events in terms of getting yourself prepared for certifications. So do check this out. I think those are really, really useful. And yeah, as I mentioned, some of it is the Google Cloud certifications. These are some interesting ones. And as I've mentioned at the start of this entire DevFest today, because we wanted to make it really easy for you to get all the links from the presentation. So you can actually just go to this bit.ly link. It will bring you to the gist, github.com, where you get all the information for all the links that we shared today. And yeah, with that, we've come to sort of the end of today's DevFest. There's actually one more that I want to share over here. As always, we are always looking for speakers. DevFest. Beyond DevFest, we'll have other events in the future as well. We'll definitely need all of you who, maybe if you have something you want to share with the community, do write in to us. Let us know, via this form link over here on the different topics that you want to talk about. And we await for your submissions. We really want to put you in some of our events, be it our webinars that we do every few weeks, or the bigger events that we have throughout the year, maybe the end of this year, or maybe even 2021. With that, we have come to the end of today's sharing and DevFest for GDG Cloud Singapore. We hope you have enjoyed what we have for you today. And if you're watching in YouTube, make sure you like, share, subscribe, all this good stuff. In Facebook, that's what, like, comment, share. So make sure you do all those stuff. Okay. Have a nice remaining of this weekend ahead. See you guys. Bye bye.